My name is Kelly Шлам. I'm from the IBM Toronto lab. I've worked at IBM for over 24 years now, and a long time in our data, database, cloud divisions, and now I'm part of our cognitive systems group. Now, I know when I use the term infrastructure in the title, it might have scared off some people. They immediately think servers, they think storage, things like that. That's certainly a part of it, but really, when we talk about infrastructure, what I'm going to be talking about today around infrastructure is both the hardware side and the software side. Let me just first ask here, how many of you here are data scientists? Okay, we've got a couple. How about ops people? A couple developers? Okay, general IT people? Anyone? All right. Okay, we've got a couple there. That's great. So yeah, I mean, when I talk about this topic, sometimes it is very targeted to specific groups, and I know sometimes the hardware aspect can scare off the data scientists, and some of the data science stuff can scare off some of the IT people. But now that we're in a phase of AI where really everyone's doing it, enterprises are doing it, things that were done in the past, maybe it was the data scientist had their computer under their desk with some number of GPUs in there and they were building models and throwing them out to whoever wanted them. You know, that's still being done depending on kind of the maturity of some of the businesses that are using AI. But more and more, there's this need to kind of take this enterprise approach to it. And so really that's what I'm focusing on here. Now, also, one thing I find people question me about is IBM. There's some young people here. You might say, who are they? They've been around for a long time, but known for mainframes and servers and things like that. But a lot is being done at IBM in the areas of AI, cloud computing, security, blockchain, quantum computing. So a lot of stuff going on. In fact, IBM had more patents in the US last year, actually for the last 25, 30 years than any other company. I think there's 9,000 patents, 3,000 of which were related to AI directly or the use of AI and other things. So it is a big research area for us. Now, this is marketing stuff. I don't want to get into this, but it's really just there to highlight, of course, why is AI important? What's it mean from a business perspective? But the fact is, you're all here. You're interested in AI, so I'm sure I'm preaching to the choir, and I don't need to explain why this stuff is important. But what are enterprises doing, or what have they been doing? Well, over the last few decades, really a lot of focus around IT and around computing in companies was around renovation or spending money to save money. So that's just looking at how can we do things better? How can we have a smaller footprint of our system? Stuff like that. But going forward, and where some of the more entrepreneurial or adventurous companies over the last few years, they've been going this road of AI. And really, kind of when we look at this curve, as I said, we kind of go from this spending money to save money to more spending money to make money. Innovation, so self-service analytics, agility, being able to put put AI and analytics into the hands of the many, not just the data scientists. There were a few data scientists here. You're special. I've never been called a unicorn before, but I know that's often used to describe data scientists. But with more and more coming, but also more and more need, there is this big push and big need for having systems, the software and the hardware that's going to help accelerate this journey for businesses. That's not working. All right. So businesses want to get here, but in fact, it's hard to do that. One thing we often say is that AI is not magic. If it was magic, maybe everyone could do it easily, but it's not. It's hard. And there's a few reasons for this. I mean, most companies, as I said, are looking to do something with AI in some capacity now, or looking to become an insight-driven business. But only 1/3 actually report succeeding here. And for those of you have been on some of these projects or journeys to somehow implement or make use of AI, there's a few reasons that this has been problematic, or some of the challenges that have come up in this area. Really, there's kind of two main ones. If you look at it, it's skills. So again, there weren't many data scientists here, but they're a main piece of the puzzle. So are the other folks, and I'll talk about that in a second. But it's a hard field. It's hard problems to solve, and again, it isn't just simply I have someone who's going to train a model and we're going to use it. There's a lot more to it than that, as I'll show. The other thing is data. If you listen to the keynote yesterday, and I've heard it mentioned a few other times in presentations, that data is important. Data is at the heart of AI. You need lots of it. You need good quality data. If you don't have good quality data, how can you trust the insights? How can you trust the models that are being generated on top of that or based on that data? You can't. The old adage, garbage in, garbage out. That's what you get. So that's been a real challenge for companies as well. And so another thing we kind of like to say is there is no AI without an IA. Catchy marketing slogan, but really what we're talking about here is you need to understand your data. You need to be able to understand its provenance. Where did it come from? Has it been changed along the way? Who has access to it? Things like that. And even then, if companies kind of understand that, they're not even sure what's needed then to take that next step and say, okay, I've got all this data, what do I do with it? How do I make it available for people to even do self-service analytics and self-service AI on? So that's really, really important. So at the crux of everything, data is kind of the major focus there. Now, I'm Canadian, and so I'm forced by law to always include a slide that has hockey in it somewhere. I'm in Russia, so I think might be a law here as well. I'm not sure, but this got cut off. But data science and AI is a team sport. So what I mean by that is, as I said before, when we think of data science, when we think of AI, we think of it being the data scientist, kind of that magical unicorn who has amazing analytics and stat skills and computer science skills and maybe business acumen and all those things. But really, for successful AI, it's multiple people involved, and not just a single one, but usually groups of people. As I said, you've got to get the data in. That's kind of the key there, right? Again, I saw this in a different way shown at the keynote yesterday around kind of, how do you train a model, put it into production, refine it, and so on. So this is just another form of that. But you're going along, you're building and training your models based on your data. You got to evaluate it. You need some help from the business. Is this looking right? Is this the kind of things we need to focus on? Should we look and perhaps take a different approach to things? Once you've built your models, you have to deploy it. Your application developers have to take advantage of it. And of course, you want to make money off it in some way. But you also have to take that next step of monitoring it and maintaining it. So again, it isn't just the case of the data scientist says, I've built this model, I'm going to throw it over the wall, the developer's going to grab it, put it into production, and that's it. You can imagine if you had a model that was doing something like predicting home prices. Over time, even though it's able to predict them now based on data from the past, things are going to change, right? Maybe it's, the economy has an impact, or, some other things like that. There's been an influx in immigration. Who knows? But over time, things are going to change. So the performance or the accuracy of your models are going to change over time. So it's really important to make sure that what you've got in production is actually still working and still valuable and still bringing you insights. But it may require retraining. So going back to that data extraction and processing process and going through this again. So, this is all very collaborative. And the last thing you want is this to be done through a bunch of phone calls. Okay, I'm done mine. All right, I'm going to do my work. Okay, I'm done my piece and move on. So if you're looking to do something with a team like this, collaboration is very, very important. So another way we kind of look at this approach is, we like these marketing tags and names, but I think this is a good one, the AI ladder. Now, the smart people in here will say that's not a ladder, those are stairs, but I don't know. I didn't create this picture, this slide, but what we like to say, just based on so much work we've done with our customers, is the foundation of you know, an AI project and the steps you kind of need to go through. You know, I showed you the true prep your data, build your model, that kind of thing. But just more generically speaking, it's about collecting your data, organizing it. Again, trust is super, super important in this stuff. Once you have trusted data, only then can you do your analysis and infuse those insights and those models you've built into your business processes. And if you look at it at a more detailed level, and the intention isn't to look at all the things under here, but just to give you an idea of all the different, you know, potential components and things that need to be done and what's involved in that. This is really tricky. There's a lot of stuff involved here. And so, you know, if you look at what people have done in the past, you know, I mentioned like data scientists possibly just having a server underneath their desk, and she's got some number of GPUs in there, and she creates her models and everything's like that. Now you start to say, okay, well, now we need to have this more end-to-end workflow. You know, let's start piecing parts and pieces and software. You know, we're using open source. Most use open source around this stuff. How do we get this stuff working together? What you end up with is this kind of monster vehicle like that there. Really curious to know if this works. I don't know if I'd want to have one. What I'd rather have, obviously, is more something like that. And this is kind of this concept of these enterprise data and AI platforms, or enterprise insight platforms. And so a lot of businesses are going down this route, which is to say that, you know, rather than trying to build all these things piecemeal, which again might work okay when you're dealing with you know, a single person or a very small team working on a limited number of servers. But once you need to go beyond that, it's just too hard for an enterprise to manage. And so kind of what, you know, we see and what many others are seeing here, and I'm going to talk about what IBM has to offer shortly, but from an enterprise platform or insights platform perspective, it isn't just limited to us. So we certainly have stuff that I'll talk to you about. Amazon, you know, SageMaker, Microsoft Azure, they've got a number of kind of tools and services around data, around AI. So there's lots of different companies out there that are doing this. So it is certainly a trend and a direction we're seeing. And of course, IT loves this, because, you know, when you have a more prescribed approach to things, when you have pre-integrated software, pre-integrated hardware, they love this. It makes it that much easier for them. But at the end of the day, you know, kind of the data scientists and the data science team, they want to have what they want, right? They've got the tools that they're comfortable with. Typically, again, open source, you know, from a development perspective, it might be Jupyter Notebooks, it might be Zeppelin, it might be R, you know, there's Python programming, you know, all that kind of stuff. So that's very, very important. And so that's generally kind of the approach that even these different platforms are taking, is to include and to embed these open source, best of breed and widely used technologies. So now just to get into kind of what IBM has to offer in this space, and I know it's a little difficult to kind of read this at this point, but I'm going to go through each of these components in a little more detail. But we've kind of broken things down into three general areas with respect to building your models, you know, building your AI solutions. So data exploration, building your models, getting data prepared. So we offer this as part of something called Watson Studio. And this is available in the cloud, public cloud. You can have it for private cloud, on premises. You know, lots of different options for you here. But we've also got something called Watson Machine Learning. And so here we're really looking more, helping along with training and retraining, but the deployment, the model management, the operationalizing of them. So in other words, you've built your model, how do I get it out there for the world, for the developers to use, and so on. And then another area is actually, you know, properly infusing these AI models and the applications in a way that's fully trusted and fair, where the models are explainable, where you can see how they're actually doing in real life, auditing what they're doing, and so on. And so while some of these other platforms are focusing on certain things, such as, like developing models or maybe even deploying them, there's not a lot out there that's kind of in this space. And so we feel we have a real differentiator, a significant differentiator here. So just kind of think of it as these being the three pieces. And then another piece I'm going to talk about is something called the Watson Machine Learning Accelerator. And I'm going to actually get into that in a lot more detail later, just talking about some of the capabilities there with respect to helping accelerate your machine learning and deep learning workloads from a training and deployment perspective, including things like hyperparameter optimization and elastic distributed training and things of that nature. So I mentioned Watson Studio and Watson Machine Learning, and I've also mentioned open source quite a bit here, because again, what we're being told by our customers is that open source is king or queen. The data scientists want it, the people in the business want it, they're familiar with it. And so that's what we've essentially done with everything we're doing is we've got it at the foundation of everything we do with respect to the services available. So as I said, notebooks, our studio, various different machine learning and deep learning runtimes, and this is a constantly evolving thing. If for those of you that have been doing data science work, you'll know that things that might have been popular from a tooling perspective or a framework perspective a few years ago might not be anymore, and there's new ones that have come along. So we're very, very much kind of in touch with what's happening and putting kind of, again, what the most widely used things in the industry are as part of that. And then it's built upon a foundation that's open as well. So Docker, Kubernetes, so containerized microservices based. It includes Spark built in, Hadoop built in. Additionally, there are some IBM value add here that are included as well. So we have some of our auto machine learning capabilities. If any of you have used things like Cognos Analytics, SPSS Modeler, things of that nature, those are a part of it as well. So it doesn't matter what your data is, whether it's structured data, unstructured data, whether you're working in the cloud, whether you're doing stuff on premises. You can use all of this stuff and use it in tandem, again, wherever you want to use it. And so this just gets into a little more detail. It doesn't really describe a lot more than what we just talked about, so I'm just going to go through it quickly. But again, if you're looking from a development build environment, Watson Studio. If you're looking for that operationalizing, deploying, managing, monitoring, Watson Machine Learning. And then I mentioned the accelerator, which I'll again, kind of dig a little bit deeper into later once I actually do get into hardware stuff around servers. But kind of some of the main points that I'll be talking about is this concept of distributed and elastic deep learning. So being able to spread out training on multiple servers. So multiple GPUs per server, but multiple servers as well. So, smart scheduling of those resources, not just training, but also inferencing, and that hyperparameter optimization I talked about before as well. So really trying to automate and scale the performance of these workloads as much as possible. Now, I've mentioned trust a few times. For AI to be successful, there has to be trust in it. The consumers that are going to be affected by this need to either, believe that it's doing the right thing for them, and I shouldn't say either, but it needs to be transparent. It needs to be explainable. If you go into your bank, your financial institution, and you want to take out a loan or get a mortgage for a home, and they say, no, you can't have it. They, in some countries, I'm not sure about Russia, but in some countries, they are required by law to be able to explain to you, or have to be able to explain to you, why they said no to you. And for those that have done data science work in the past, where you're using some some model you've downloaded somewhere, you've trained it on your data, or maybe you're even going that next step and it's building an ensemble, or it's kind of using multiple models to come up with this final model. Good luck trying to explain data going in, result coming out. Very, very difficult, right? And so there's a big push on this. And just because you're using an algorithm doesn't need to mean it's going to be fair and just. I was in one of the presentations yesterday where they talked about, it was around the justice system, and looking and using the data of people and how much time they were sentenced to for particular crimes. And the model happily said, oh, okay, based on this data, here are my predictions. Here is how I would then sentence these new people coming into the system. Problem was, certain sectors of society, socioeconomic, different ethnic groups within the population were being perhaps treated unfairly in the past. That gets propagated with these models that are being built upon it. So there's a real push, again, to be able to explain and be bias-free, be fair with respect to this. So this is all very, very important going forward. And so the other component I had talked about was Watson OpenScale, and that's where this comes in. Trust, transparency, being able to actually explain why decisions are being made, helping root out or helping find bias in the data. It might be that something based on sex comes and says, okay, the answer is this, but maybe you gave it 90% of the data was male and 10% was female. And so it didn't come to a fair conclusion, or doesn't come up with a fair prediction based on that. And so these tools, and again, there's others happening. It's a fairly new research field that's out there. This is helping to mitigate these kinds of things. So now just looking again, this was the same slide I showed earlier. Watson Studio for data prep, for data exploration and starting to develop your models, training your models, managing them, monitoring them, auditing, fairness, bias. All of this stuff is covered end to end here. So again, while there might be other platforms out there, they don't all necessarily have that. So in addition to those, another offering that has been out about a year now actually takes those things and puts them together. So that stuff was great if you've got a departmental kind of AI team. One thing I don't know if I mentioned, but collaboration being a big part of that. So you've got an interface that lets you actually share and collaborate the source code, the models that are built, being able to look at what you're building and have others see it and use it and build off of it as well. And so we've taken all of that stuff and we've put it together with a lot of other stuff as more of a kind of a platform as a service, which you can actually run on public cloud, private cloud, doesn't really matter where. So you should see a theme here, very much embracing open source, very much about being open and avoiding vendor lock-in as much as possible here. But what we've done is kind of looking at those rungs of the ladder. Remember the collect data, the organize data, the analyze data, putting some capabilities in there around that, utilizing things like Watson Studio, Watson Machine Learning. In addition to that, we've actually got services for like databases and data services, and not just IBM stuff. Not everyone's an IBM customer. I wish they were, but the reality is many are not. And so things like NoSQL databases, like Postgres, like MongoDB, you can actually get these as add-ons for the system. And it's very cloud-like, it's very agile. I hate using the word agile, but it's self-service. So you can go in, click some buttons, and boom, I've got a MongoDB instance. And click a few more buttons, and I've set up a Watson Studio environment for someone. So very, very simple to get up and running. And again, the whole collaborative approach where teams are able to work together on stuff is very much a key part of all of this. And of course, as a platform, as something on which an organization or a department is going to work, you need to have your cloud type operational services, things that enterprises care about, security, storage, metering, being able to do chargeback is something that enterprises are getting into as well. So let's say they're setting up an environment, they want to be able to perhaps open up something as a service for their customers. But then knowing that this customer X, used some amount of, whether it's API calls or is using some amount of storage or processing time or network time, being able to do chargeback on that. And all of this is built in a, like container Kubernetes, the Kubernetes-based environment, so that, again, all done in this kind of microservices, extendable, flexible type of approach here. And again, we're really trying to make this open, and that also includes the data. Not just structured database data, but unstructured data. So Hadoop, Spark, NoSQL databases, all of that included as well. All right, so as I said, we kind of packaged up the Watson stuff together as part of Cloud Private for Data. So this is just showing that as a bit of a summary. Again, open source for those that are doing AI work, a big part of this. Now, I've mentioned data. I've mentioned how important it is to understand your data, to trust your data. Governance, integration, all very important things. Again, if you can't trust the data, you can't trust your insights. You can't trust the value, the results that are coming out of it. So it's fully enabled from data integration, replication, regulatory templates associated with it. If you're in a specific, like the financial industry, there are templates around this to be able to govern your data, to catalog it and transform it. So all of these services are built into that IBM Cloud Pak for Data environment as well. All right, so that was kind of mainly on the software side of things, and so now maybe I'll put you to sleep a little bit with some hardware aspects of it. Now, if I had a longer presentation, I would typically get more into specifics around GPUs and TPUs and FPGAs and ASICs and things like that, but don't have the time and I don't have the ability to get that deep. But at the end of the day, what enterprises, what companies are looking for are the same things they've been looking for years in their operational back-end systems and front-end systems as well. Reliability and availability, performance, security, cost effectiveness, very important. And in fact, as we are now in this age of containers and Kubernetes and deploying software this way, that's getting more and more important as time goes on as well. And I'll talk about that a little bit too. So here, I just wanted to highlight, because it does play the foundation or gives the foundation of IBM's AI story. So while I did talk about the software already that says, hey, you could put this stuff anywhere. You can have it out in the public cloud. You can put it on Azure. You can put it on Amazon. You can put it on IBM's cloud. That's great. You can put it on-prem. You can put it on x86. Again, trying to be very open here and not lock people in. That said, we do have a very thriving, strong business around our power servers. How many of you have not heard of IBM Power Servers? None. Okay, there's a few. So either everyone's asleep or everyone knows this stuff, but it's PowerPC, basically. A couple decades ago with Apple, and basically though we've maintained that. We've actually gotten out of the x86 business, but we still, everything we do pretty much goes on x86 as well. But specifically, I'm not going to talk about our line of servers, but there is one, the AC922, and that stands for accelerated computing, but who cares about the numbers? But really the important thing I want to say is it was designed for AI. And I'll explain what that means in a second, but it's not just us saying, yeah, it's designed for AI. It's actually the system behind the #1 supercomputer in the world. We've actually got a few in the top 10 there, but we hold down, IBM holds down the #1 and 2 places on the chart, with the #1 place being used using AC922s. And this isn't specialized stuff we've built together. A lot of times when people build these supercomputers, they put their very best, they're very unique, very proprietary. What we've done is actually taking those AC922 servers that you or your company could buy and put them together. So they're, InfiniBand cabled, and there's a ton of storage that goes along with this stuff. And you can see, well, this doesn't show, but like 2.5 million cores. And I mean, I think that's including some of the GPU cores as well in there. But, the same things that people can buy and use are at the heart of this. And I mentioned the kind of effectiveness and the efficiency of using systems. And at one point, and it's still this case today, virtual machines, right? How many virtual machines can I get running on this server? And that certainly comes into play still today because the more you can do, the more stuff you can put on there, the more use you're getting out of your systems. Maybe you're able to consolidate and you save on heating and cooling and stuff that IT people care about. But you're also now in this container world being able to shove more of these containers together on hardware. And and that makes a difference oftentimes to developers and people working on stuff like that. So Power Systems has got a very strong story around container efficiency. Now, from an AI perspective, one thing I wanted to highlight is the way that it does communication between the GPUs and the system. So anyone who's done training work with machine learning and deep learning workloads, the topic of GPUs always comes up. GPUs make things faster. You're going to be able to train your models faster if you're using GPUs. And so part of the AC922 is a number of these NVIDIA V100 GPUs. But what's really special and unique about this particular server, again, I won't go too deep and bore most of you, but is this special NVLink bus that's there between the CPU and the GPU. On x86, this exists only across GPUs, but on these Power 9 servers, it also exists there. And this allows for very, very fast communication between the GPUs and the CPUs. Again, without going deep in the hardware weeds here, what it means, though, is you're able to do things like coherent memory access to your memory. So while, if you're not dealing with that kind of thing, traditionally, although some work is being done around this, if you're doing, training models and feeding data to it, they've needed to fit on the memory on these GPUs. And today, these things are like 16 gig, 32 gig of memory on the GPUs. But by being able to have very, very fast, near CPU memory access speeds here and bandwidth, you're able to effectively do a lot of swapping of data from memory to and from the memory on the GPUs. And so what that means is now you can start dealing with larger models. You can start dealing with larger photos or videos or whatever it is you're dealing with. So that's unique to the AC922. So this is just highlighting again kind of this what we call large model support, which is to say that typically without this NVLink 2.0 processing, you're limited to PCIe 3, and it just means that the ability to be swapping data in and out, while you can do it, the performance hit is quite high. So you're taking a real performance hit to do that. So ultimately what happens is, let's say people are doing image processing. They got to make their pictures smaller. Right? You can imagine that if this is MRIs and this is medical imaging, you don't want to have to reduce the resolution of your neural networks, of the data you're dealing with, right? You want to have as high res of data as possible. And that's what you get with this large model support that comes with, basically it comes as a partner between our AC922 technology as well as that Watson machine learning accelerator component I talked about before. And so just to kind of show you what's happening under the covers, this is just a test with NVIDIA's own DGX1 server versus an AC922 using the exact same GPUs, just that because of that NVLink 2.0 between the GPU and CPU that's there on the Power 9, it's it's able to get data in and out faster, which means that it's able to actually do its work. The blue, this is showing GPU utilization. You can see a lot of white. That's a lot of space where it's doing nothing. It's just waiting for data to be copied in from memory here. But because of that NVLink, boom, it's getting stuff in quick, and it's able to do things 2.5 times faster here. So another capability that this allows, that this accelerates, and again, through the use of that Watson machine learning accelerator technology, is something called distributed deep learning, which is taking your training work, the code you've written for training, and actually, rather than training it on one server that maybe has a GPU or 2 GPUs or maybe even 4 GPUs, you can actually distribute it out across multiple servers with very little coding and API calls that need to happen. So for the most part, you can take the code you have, make a few minor changes, and be able to distribute it. So here's a case where on one system, training a model took 16 days, had a cluster of 64 systems, able to bring it down to 7 hours. Here's just showing the kind of scaling you get with it. This was scaling, I can't remember how many servers it was, but it was dozens of servers, being able to scale up to 256 GPUs. We actually just had a customer that's implemented this with over 1,000 GPUs. So they're able to actually do this distributed training across all like 1,000 GPUs in a way where they're getting this kind of near linear or near ideal scaling. Another capability that comes with the AC922 and the Watson Machine Learning Accelerator is this concept of elastic distributed training. So what happens oftentimes in a department, if you've got very limited resources, you have, let's say, a server with some number of GPUs, and when the data scientist kicks off a job and says no one else needs it, no one else is using it, I'm going to use all of the GPUs. Then a day later, their coworker calls and says, oh, I need to do something important. And so they say, okay, I'm going to kill my original job. Now I'm going to set it up so we'll both run. And maybe someone else calls and says, no, I need a GPU now, or the boss is on my back. I need to get this work done. What this elastic distributed training says is we can, under the covers, allocate resources, just like a resource manager, a scheduler, and actually say, okay, at time 0, one job's running. It's using all 8 GPUs across, let's say, 2 servers. Someone else comes along and it's got fair share policy and says, okay, I'm going to split them up without having to kill this stuff. It actually will, on the fly, dynamically start to adjust the usage and who's using the GPUs. Then maybe someone else comes in, or maybe the priority gets changed, and so on. So you can see that this is really, really effective at maintaining efficiency for the data scientists and those that are building models. And I mentioned this a couple times before, but hyperparameter tuning. So for those of you that aren't data scientists, I won't even begin to explain what these things are. It took me a night of reading through this stuff to try and figure it out myself and understand it. But ultimately what it comes down to is there's a bunch of parameters that can be adjusted, that perhaps can influence your model accuracy. All of this is a very, very iterative process. So what we do is we automate this. We actually kick off a whole bunch of jobs with different parameters, look at them, see which one's doing better, and using various algorithms, we can approach what we think are good hyperparameters for the workloads that are being done. All right, so just, whoops, and as I said, from a data curve, data acumen perspective, most are here, most are ready to jump in. 99% said they want to become an insights-driven business, but how do you do that? Well, with the capabilities I've talked about here, the cognitive infrastructure. So again, what I mean by that, that's the hardware, that's the software. That's all very important. Trusted data. I can't say that enough. In fact, I've probably said it so many times, but you need to be able to trust. You need to be able to understand and trust the data. Collaboration, very important. Explainability, bias, fairness, all that stuff is really, really important going forward. And of course, open source is something that most people are looking at to avoid any kind of vendor lock-in. So with the capabilities I've talked about, hopefully you can see how we're helping you get to that point. So just to end, There's that one tag or phrase I mentioned before, but there is no AI without an IA. So it's very important to kind of, again, understand that whole data and AI workload flow. But true cognitive systems, things that, again, maybe if you're working in a small shop where you're the only data scientist, you don't care about this so much. But if you're in an organization that's getting bigger, that's looking to do more with this stuff, you are going to start looking at this combination of hardware and software. So keep that in mind as you go forward with this. Whoops. So with that, that's everything. I know I talked quite a bit here, but any questions that anyone has? If not, I'm going to be outside at the, I guess, the couches over there afterwards, and happy to talk to you. Any questions on Slido?
Есть вопросы к спикеру? Так, пока есть, да? Отлично.
Hello, thanks for the very nice introduction to the IBM infrastructure. Question: what is Power AI is?
Oh, what is Power AI?
Yes.
Okay, because you saw it on one of the charts there. So that's actually an old name. So one thing that IBM does very, very well is change its names of its products all the time. And so we used to have this thing called Power AI. This software I talked about with the distributed deep learning, the elastic distributed training, hyperparameter optimization, that used to be called Power AI. But then we said, well, let's make it available to everyone on x86 as well. So we wanted to take the power out of the name, and our marketing geniuses came up with Watson Machine Learning Accelerator. So that's really what it means.
Okay, got it. Thanks. So it's a previous name.
Yes, that's exactly right. Long answer to say it's a previous name. That's right.
Thanks.
Еще вопросы есть? Так, да. Если появятся вопросы, спикер наш будет стоять в уголке Ask Me Corner по коридору и налево. Всем спасибо за внимание. Thank you so much.
All right, thank you very much. Thank you.